Hello, everyone. A hot glue gun is definitely a familiar tool for any DIY enthusiast, thanks to its fast heating and quick adhesive capabilities. However, this glue gun of mine is having some trouble. When I plug it into the power outlet and flip the power switch, the gun stays completely dead. The power indicator light fails to turn on, the glue stick inside doesn't melt at all, and the nozzle remains ice cold without emitting a trace of heat. A clear sign that the internal heating element has completely failed. Instead of throwing away a broken appliance, a really cool idea suddenly popped into my head. Converting this dead glue gun into a super handy mini soldering iron. Let's jump right in and get started. First, I use a screwdriver to remove all the screws one by one to split the plastic casing of the glue gun open. Every like and subscription motivates me to create more creative DIY projects. Thank you so much for your support. Upon inspecting the inside, I realized that the internal heating element and wiring are completely damaged beyond repair. Therefore, I strip out all the old components, keeping only the hollow plastic shell to serve as the body housing for our new soldering tool. Next, I take an old motorcycle inner tube and repurpose its metal valve stem to craft the primary heating element setup. I use scissors to carefully cut the valve stem away from the rubber casing. Then, I prepare a section of heavy-duty electrical wire to serve as the main power cord for the device. I strip back the insulation at the end of the wire and split the copper core into two separate bundles, making the connection process much easier and more secure. I wrap and twist these copper strands tightly around the valve stem body to ensure excellent electrical contact. Finally, I fit the valve stem right into the front nozzle slot of the glue gun housing, align the matching half of the shell, and tighten all the screws firmly back in place. To make the heating element setup even sturdier, I slide a washer onto the valve stem and tighten a hex nut firmly right at the front nozzle of the casing. This step anchors the metal valve stem rock solid in place, preventing any wobbling or movement when applying pressure during soldering. After that, I strip the outer insulation from the remaining wire end of the soldering device to prepare for connection. Next, I attach an alligator clip securely to this wire end. Equipping an alligator clip allows for quick, safe, and firm clamping onto power source terminals like a battery or power supply, ensuring a stable current flow during operation. Next, I'm going to repurpose an old used battery to craft the soldering tip for the tool. First, I use pliers to carefully peel off the outer metal casing of the battery. Then I use needle nose pliers to grip the internal carbon rod and slowly twist it out to extract it intact from the shell. After that, I use a paper towel to wipe the carbon rod clean, removing all chemical residue and dirt clinging to its surface. In the next step, I clamp the carbon rod into a power drill chuck for shaping. I turn on the drill to spin it evenly while pressing the tip of the carbon rod against sandpaper to grind and shape it into a tapered point. Grinding the tip creates a smaller, concentrated contact point that perfectly suits a mini soldering tip setup, making it much easier and more precise to apply heat right where it's needed during soldering. Once the carbon soldering tip is fully shaped, I insert it securely into the metal valve tip of the device. Right here, I have a working power drill. I'll remove its battery pack to use it as the direct power source for our soldering system. Next, I insert two metal washers into the battery's electrical contact slots to serve as connection terminals. Then, I connect the main wire of the soldering device to the washer on the positive terminal and clamp the ground wire's alligator clip to the washer on the negative terminal. The moment the tip of the soldering tool touches the contact point, electric sparks instantly flash. This indicates that current is flowing and generating intense heat, making it fully ready for practical testing. For the first test, I'll weld two razor blades together. I touch the carbon tip directly onto the contact seam of the two blades. The electric arc instantly generates extreme heat, glowing and fusing the metal surfaces together in a split second. Afterwards, I tug on them to test the bond strength. The weld holds remarkably firm, keeping the two metal pieces perfectly stable without breaking apart. Moving on to the next test, I'll use a soldering tin wire to create a clean, solid solder joint right on the tip of an electrical wire. For the final test, I'll use the device to repair the broken handle of a metal cup. I apply the soldering tip directly to the crack to reinforce it. Once finished, I test its strength by tapping the cup on the table. The handle is securely fixed and holds up remarkably well. And there you have it. From a broken hot glue gun and a few simple recycled parts, we've turned trash into a unique and super handy mini soldering tool. If you enjoyed the video, please like and subscribe to support the channel. Thanks for watching, and see you next time.